So this is our third class for the DC circuit discussion, which is, and today we're gonna learn mostly circuit calculation, and we're gonna have a small bit of recap from our last class so that we can actually go ahead and do the circuit calculation with ease. So first of all, what I would like to take the attention to, I'm gonna use this much square space as best as I can. So first I'm writing that the formula for series calculation goes like this, that rs equals to r1 plus r2 plus r3 plus dot 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 dot. The common combination, the common resistance for parallel combination rp goes like this, bracket r1 inverse 1 plus r2 inverse 1 plus r3 inverse 1 plus dot 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 whole inverse. And then we have the Ohm's law, which is V equals to IR, to be applied in applicable cases relevantly. And that's pretty much it for that. We are going to require to do circuit calculation, but we have to use some significant portion of our brain to be able to practically be able to truly solve this problem. To understand, in our last class, I showed you the little bit of the example for series combination, and then I showed you a bit of a parallel combination. In many cases, combinations can be compound. Compound means within a series combination you can have parallel components, and within a parallel combination you can have series components. So I would like all of you to have your copies at hand, because what I'm going to make you do today, you're going to have to do some actual calculation on your own in your copy, and you have to give me feedback, and you might also have to write something down for today's class. So write this down, that this is lecture 2 at today's date. Today is, I think, 22 21, and then let's go on for take it from there. So if I give you a very simple example for parallel combination embedded within a series type combination, I can show you like this. For example, let's say this is a type of combination that we have named as R1, R2, R3, and R4. So you can see that what the primary way that we should think about this thing is that whenever current is going to come enter into this circuit, is going to go through R1, and then the whole current is going to go through R2, and then the current is going to get split into two parts for the R3 and R4 branches. The split currents are going to go through the R3 and R4 branch, and then they're going to come down over here, merge at this point, and eventually they're going to come out as a whole once again. So what we should see, that the current is between through R1 and R2 is exactly same, because they are connected in series. And the current to R3 and R4, the sum of current of R3 and R4, I mean I3 plus I4, the current of R3 and current of R4 resistance 4 are named as I3 and I4 respectively. So these two current sum would be equal to the main current as well. So we pretty much consider this whole thing, I mean this whole thing is considered as a series combination. We consider this whole thing as a series combination, whereas we consider that this is a series component, which we can see as a single component. This is also a series component, which is you can see as a single component, and this entire combination that we have seen over here is considered to be one single series component. And there is a way this combination should be described properly. I mean, the position of the description and the use of appropriate commas in places matter a lot, and you cannot mess this up, because they might mean different things compared to what you are trying to mean. uh, we can try to explain this, describe this combination in a lot of different ways. One of the very simple ways, if I want to go for two different sentences, I can say that R3 and R4 are in parallel combination, full stop. Think about it. R3 and R4 are in parallel combination, full stop. This combination is in series with R1 and R2. This combination is in series with R1 and R2. Or you can say in a similar way that R3 and R4 are in parallel combination, full stop. R1, comma, R2, comma, the parallel combination mentioned earlier are in series. We can also write it this way. If you want to write it this in one single sentence correctly, this is how you can write one single sentence. You can write R1, comma, R2, comma, the parallel combination of R3 and R4. This whole thing mean one single component in this case. The parallel combination of R3 and R4 are in series. This is an appropriate, this can also be accepted as an appropriate description for this combination type. I'll say this again. R1, comma, R2, comma, the parallel combination of R3 and R4 are in series. I want all of you to write these stuffs. Please draw this circuit within your copy, only this much, and then underneath this thing you write description of the combination, and then you write with ORs. First you give a bullet and then you write আমি কি বলা শুরু করবো? তোমাদের আঁকা হয়েছে?
জি স্যার।
ওকে, সো ফার্স্ট ডিসক্রিপশনটা লিখো, সেটা হচ্ছে R3, R4 are in parallel. R3, R4 are in parallel. Full stop. তারপর লিখো this parallel combination is in series with R1 and R2. So this is your first bullet. Then you're gonna write OR and write the second bullet. ফেলে দিছে, sorry. All right, sorry, আমার বাবু মুখ থেকে কলা ফেলে দিছিল. So, or in the second description you can write R1, comma, R2, comma, the parallel combination of R3 and R4 are in series. Full stop. So এই দুইটা হচ্ছে there can be a lot of different other set of wordings that we can make to write the description of this combination, but I personally like these two formats because they usually are pretty eloquent and are not to be cannot make double meaning. One of the most common mistakes when students try to write about this thing is that they seem to they sometimes write the description of this kind of combination like this, that R1 and R2 are in series, R3 and R4 are in parallel, and together they are in series. Now this might make sense, this might not make sense. So what sometimes they propose, they using this with that these two are in series, these two are in parallel, and these two are in series. This is actually correct, this is not incorrect, but if you can write it in this manner, this is all right. But I personally don't like it this way because what I want you to visualize that here within this combination we have three components contained in series. This one first, second, and whole of this thing third. I want you to see three different components contained in series. All the series components should be considered one at a time. You should not consider that there is one series combination over here, there is one parallel combination over here, together they are in series combination over here, because that is simply more steps towards your goal. This is not incorrect, this is just unnecessary. And the way that students can write is that also that R1, R2, R3 are in series and R4 is in parallel. So hear me out on this one. I'm not making you write this thing, just hear me out. I'm going to say it slowly. Let's say write this thing that R1 comma R2 comma R3 are in series, full stop. R4 is in parallel. So this is a highly ambiguous description, that because it simply primarily proposes that these three registers R1, R2, and R3 are making a series combination. That's for sure. And then the student says that R4 is in parallel. Now, R4 is in parallel with what? One of them, two of them, three of them. R4 is parallel with yourself, with the examiner. What? You have to mention that where the R4 is located. So that's pretty important for the description of the part. Many of you might feel like that, why am I taking so much time in describing the circuit? Because whenever you are able to describe a circuit by looking at its structure in your head appropriately, only then, in my opinion, as far as I've seen, you are able to apply the formula for calculation properly. So I can write the combined resistance formula for this combination like this. The total resistance, I'm going to use the symbol sum of resistance or total resistance. I can write it as R1 plus R2 plus R3 inverse 1 plus R4 inverse 1 whole inverse. I'm going to write it in this format. This is a series combination, so three components are added together, whereas the last thing is a parallel combination. This is the total parallel combination equivalent resistance. That's how I would prefer to write. Do you understand this expression, everyone? এটা কি বুঝা যাচ্ছে?
Yes, sir.
সবার ক্লিয়ারলি বুঝা গেছে?
Yes, sir.
আচ্ছা, সো এখন আমরা আরেকটা কাজ করব, সেটা হচ্ছে we're going to apply a certain voltage source over here and we're going to try to solve this circuit for different parts. Now, for the sake of simplicity, I'm going to give you one simple rule of thumb. সেটা হচ্ছে, in your actual exam you can have a lot of different resistance values connected in different places, which is very much possible. Just for the sake of simplicity, the way I prefer to solve questions is that whenever I'm going to use resistors with numbers in the circuits, the resistors are going to have values that is simply 10 times their number. For example, R1 will be 10 ohm, R2 will be 20 ohms, R3 30 ohm, R4 40 ohm, so on and so forth. Just a second, Balaban. So this is the way the circuits are going to have their values. This is how I'm comfortable to work with. But in your actual exam, you can have a lot of different values, and if you know how to handle the circuit, you can handle any type of values. That's not actually a very large matter. So I'm going to connect this combination with a battery source, and we're going to try to solve this problem for multiple values. Now, let me tell you what I mean by that. Let's say this is the circuit that we're going to try to solve. So 1, 2, 3, 4. And then over here, let's say we have connected a battery. This battery is, let's say, 12 volt. And here we have R1, R2, R3, and R4. So if I ask you in normal sense that calculate the variables for this circuit, if I just ask you that solve this circuit, if I only say to say these three words, what does this mean is that you have to calculate multiple things out of this circuit. I'm going to write those things right over here so that I can do the calculation right in here. So I'm asking you, first of all, you to find out the common resistance of the circuit. Then I'm asking you to find out the main current of the circuit, which is represented by only I. Main current means the current that will be coming out of the battery itself, only the current coming out of the battery, the full current coming out of the battery. Then I'm asking you to calculate the individual currents and individual voltage drops of all the components, which means I'm asking you to calculate I1 equals to what, V1 equals to what, I2 equals to what, V2 equals to what, so on and so forth for all the individual components. This is what I'm asking you to do to whenever I say that solve a certain circuit. Now, We're gonna solve the circuit step by step, and I'm gonna try to make sense with you so that you understand how this works. This is a very simple circuit, to be honest, if you ask me. But we have to remember in our head that the core three things that we will be using to solve the circuit is these three mathematical formula. That series has R1 plus series a common resistance of R1 plus R2 plus R3. Parallel has a common resistance of inverse plus inverse plus inverse dot 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 whole inverse. And Ohm's law is given by V equals to I. These are the only three mathematical equations we're gonna use. But additional to this, we should also remember one very important thing, that is current in a series circuit is always same. Current in series is same, and voltage across parallel branches is also same. Now, what do I mean by this? What I mean by this is that if you have a look at this circuit, if you have a look at this circuit, have a look. When the current is going to come out of this battery, this current is going to essentially flow. This same current is going to flow through R1. The same current is going to flow through R2, and then the current is going to get split into two parts and get different values. It will flow through R3 and R4. So if I can somehow, for this circuit, have a look. If I can somehow calculate the value of I can very easily say that this same value of I will be equally applicable for R1 and R2 both. This would not be equal to I3 or I4, but if I consider this whole thing, if I consider this entire thing as a single component, let's say if I name that component as R34, this is not 34, this is our I'm trying to mean that this is the combination of 3 and 4, whatever combination. In this case I have parallel combination, so I'm going to handle it like a parallel combination. I'm going to show you the steps after a while. So this whole thing is considered as a single combination. I'm naming this as R34. So the current that will flow through R34 can be named as I34, which would be exactly equal to as I1, which is exactly equal to I2, and which is also be equal to the main I. Now, do all of us agree with this expression? এই এক্সপ্রেশনটা সবাই বুঝতেছো কিনা খেয়াল করো। The current that will be coming out of the battery will be same pass through R1, same passing through R2, and that same current should be passing to the entire combination. Now, individual branches will have different current, that's for sure, but together, all the branches summed up together will also be responsible to carry the same amount of current from left to right. Is this information acceptable?
Can you explain why I34 will be equal to I1?
I34 in this case means the combined current that will be flown through I3 and I4. The total current that is carried down the path by the whole of this combination. So you're going to have some current reaching up over here. At this junction, the current is going to split up into two parts. And I mean, if you have 10 ampere coming in over here, whatever the fraction that they divide in, the sum of these two currents has to be 10 ampere, because this point cannot store charge. So whatever the current that comes in, that has to divide into parts, so that the sum of the parts would essentially give you the whole. It's pretty much like the idea for like water flow path. I mean, if you have 10 volume per 10 meter cube per second coming in, if you have two channels leaving from that point, the sum of those channels should be exactly same, because if that is not same, you're going to have flood. That's not going to happen. Current has to be equal for, I mean, the sum of the current of these two branches must be equal to the incoming current, because charge will not be stored over here, or not charge will become vanished over here. বুঝতে পারছি?
জি স্যার।
আচ্ছা, so considering that part, so আমি যদি এখন এই পার্টের ক্যালকুলেশনটা একটু করি, আমি ক্যালকুলেশনটা তোমাদের করতেছি, তোমার ক্যালকুলেশনটা একটু খেয়াল করো. If you have any question at any point, you please ask me about it. I'll help you sort this out. So let's just give a line. So the first thing I'm going to do is I'm going to calculate R34, because I might need this value after a while. This is 30 inverse 1 plus 40 inverse 1 whole inverse. Everyone please draw this circuit up and eventually help me do the calculation. And you should also copy these calculation parts, because this will be needed for you to be able to participate for the upcoming part of the lectures. So how much do you get from here? Can someone make me host? For reasons unknown, I got disconnected. Samira,
Yes, sir.
can you make me host?
Sir, you are the host.
Then why do we have green circles? Oh, acha. Did I be, did I get disconnected for a while?
Yes, sir.
Yes, sir, first.
But I did not lose my host position.
I became the host, and then when you came, you again became the host.
Acha, acha. Okay, anyway, I think my something happened to my internet connection. Okay, so how do I? Are you seeing the entire screen? Is the screen sharing on?
Yes, please, sir.
Okay, the screen is back. All right. So this is the value that I have, and like I said, told you earlier that whenever I'm doing calculations for the in-between values, I always prefer to have numbers which are up to 4 decimal places. This is what I certainly appreciate. So I'm not going to, if I'm ever writing my answer, my final answer, I'm definitely going to write up to 3 as a value, but I prefer to keep them in this format over here. If you don't want this many decimal places, okay, you can actually reduce the number of decimal places. I'm comfortable with 4 decimal places. That's just a totally personal preference based upon no CIE recommendation. I just like it that way. That's all. So then if I calculate the total resistance of the circuit, which will be R1 plus R2 plus R34, which can be written as 10 plus 20 plus 17.1429, which gives me 47.1429. So this is one of my answers, because this is one of the asked thing. This is one of my answers. So I'm writing my one answer over here. Then I can calculate the circuit's main current. I is given by V divided by R. So in this case, the R is V is the battery voltage, and the R in this case meaning the total combined resistance of the circuit. That's why I'm using the symbol sum. If you want, you can skip the sum symbol. I mean, that's not a big deal. I'm using the sum symbol because I just like it that way. You can only write R, or you can write RT, capital T, T representing total. That can also work. No big deal. So V in this case is 12 volt, and total common resistance is 47.1429. So if I do the division, we get 0.2545, 0.2545 ampere. I'm not sure what is happening to Zoom services. My internet seems to be working very perfectly, but I think my Zoom account is having some sort of issues. Anyway, so this is the current that we have over here, and this is one of my answers as well. So I'm going to write answer at the bottom of this information, but I'm going to also write over here. Have a look. This I can be considered to be equals to I1, which is also equal to I2, which is also equal to I34, the combined current of this thing. Writing this information is crucial for you to understand. Can we write this? Can we write this logically? Is it acceptable? Think. Kids, you should see that I did not label I1, I2, I3 over here, but you should understand I1 means the current that flows through resistance 1. I2 represents the current flow that happens through resistance 2. I34 is the combined current that flows through the combination of resistance 3, 4. So they are, that's how they are named. So এটা বুঝছো সবাই? এই লাইনটা ঠিক আছে কিনা? Are you okay with this one?
Yes, sir.
ঠিক আছে? Acha. So if we have to calculate the I1 values, it's very simple that we do is, and it is very obvious that we should calculate the necessary value, that V1 equals to I1 R1. So from here we can calculate 0.2545 multiplied by 10. So whatever you get over here is your V1, and then you can calculate V2 equals to I2 R2, which can be given as 0.2545 multiplied by 20. So you're gonna get 2.545 volt, and here you're gonna get 5.0909 ভোল্ট। এই হচ্ছে এই পর্যন্ত 0.09। ভোল্ট। এবং এই হচ্ছে ক্যালকুলেশন। এখন এরপরে আমরা আমরা আমাদের এই R1 R2 পর্যন্ত we are done calculating for R1 and R2 because we also have also calculated the I1 I2, so this is also one of our answers, this is also one of our answers, this is also one of our answers, and this is also one of our answers. So I'm double underlining them so to label them. Then we have to be able to calculate the current and the voltage information for R3 and R4. Now, one thing that I can always write from the property of what we have learned earlier, that within a series combination, all the components connected in series together, they will always consume the equal amount of voltage that is supplied for them. Which means here we are seeing there are three series components connected. One is R1, one is R2, and the third one is the parallel combination of R3 and R4, which we have named as R34 right over here. Together, all three of them, which means V1 plus V2 plus V34 combined voltage of this whole thing should be equal to 12 volt. So I'm going to write this equation over here and see if it makes sense. V1 plus V2 plus voltage of 34 together should be equal to 12 volt. Do you agree on this equation? I can skip the volt over here. এটা কি বুঝা যাচ্ছে পোলাপান? This is applicable because this is a series combination. Within a series combination, the series components combinedly will eat up or slash, they will utilize all the provided supply voltage. No matter how big or how small of a supply voltage is given, they will always consume the total supply voltage from the source. So the reason I wrote it in this manner, I mean, there is an alternate way to do this thing, but I'm going to show you this that in a bit. The reason I'm doing it in this manner to show you the idea of subtraction, because now we can calculate the V34 very easily by subtracting 12 minus V1 plus V2. So if you do write up these two values and do the subtraction, and please do this in your calculator and tell me how much do you get. This is the voltage value that I'm getting by the subtraction of these two numbers, and this is equal to V3 and V4. Once I get V3 and V4, the obvious next step is to calculate I3 and I4. And I can very well show you that calculation. But before I show you that calculation, I would like to show you an alternative method. Other than doing this one, this something and a subtraction, we can also go this one. I'm writing or. I could have also written that V34 should be equals to I34 multiplied by R34. This is Ohm's law. Same thing, V equals to IR written for the combination of 3 and 4. Now, interestingly, you should find out that you know what is the value of I34. There is somewhere within this calculation. Can somebody tell me what is that value? Where is I34?
0.2454.
0.2545.
Yes.
0.2545, which is over here. And we have also calculated R34. How much is that?
17.1429.
17.1429. These are the two values that we have already calculated over here. So other than going for this sum thingy or the addition thingy, we could have also multiplied these two numbers and conveniently find out the V34. So this would be equals to 0.2545 multiplied by 17.1429. এই দুটো মাল্টিপ্লাই করে দেখো তো কত আসে।
So 4.3628.
So we're getting 4.3628. You see, I have a significant difference over here, but I don't have any difference up to 3SF value. Do you see that? I'm getting 4.36 and 4.36 are exactly the same. I have some problem at 4.1 and 2.8. Do you see this? Do you see this clearly? Up to
Yes, sir.
3SF, I have the same digit. That's the reason I always prefer to maintain 4 decimal places, because by my experience, 4 decimal places typically helps to avoid this kind of round of error and consecutive round of error problem pretty easily. So that's what I'm saying. So if you want to calculate V34, you can either go by this manner or you can also go by the subtraction manner. Anyone that pops up in your head in the exam hall, anyone that you feel to be that you're comfortable with, you can apply, you can adopt that one. No big deal. There is no hard and fast rule that you should be doing this or you should be doing this. Either of them are equally correct and equally acceptable, although you might get different values, but you are going to get full marks anyway. So we have these two numbers over here, and then once we know the value of v3 and v4, it is very simple to calculate i3 and i4. So I'm going to write the equation for resistance 3. V3 equals to i3 r3. From this equation, if we subject the i3, we're going to get v3 divided by r3, which is gonna be I can use I'm gonna use the top one. It's gonna give me the same number for 3SF at the end of the day, so it's not a big deal. 4.3641 divided by 30, so whatever you get over here. And in the same manner, I can go ahead and calculate I4. So I4 would be given by V4 by R4, which would be 4.3641 divided by 40, and we get this number from here, and that's basically our I4. And someone tell me these numbers.
The first one is 0.1455.
And the second one,
Second one is 0.1091.
0.1091. Okay, there is one more thing that I could also do, optional speaking, that once you calculate the value of I3, I4, you can either go for Ohm's law, you could do this one, this is okay, or there is an alternative way, or you could do that I4 can be also calculated by I minus I3. See if it makes sense. Have a look at the circuit. Main current comes in, split into how many parts? 2 parts. So if you know the current flow that is flowing through I3, by subtraction you can very easily find out the I4, because this is getting split into 2 parts. So I3 plus I4 gives you I. So I4 should be equals to I minus I3. So you can do this as well. So alternately, if we, other than doing Ohm's law over here, if we did the subtraction over here, I'm showing you all the different methods to give you a holistic idea that how this maths can be approached. In an actual exam, you never have to do all the steps or all of these alternate steps. You never have to do this whole much of a big math. No, you will never have to do that. In the exam, what they're gonna do, kids, try to understand. In the exam, what they're gonna do, let's say they give you this exact circuit. Let's say these people give you this exact circuit, and they're simply gonna ask you a very small question. Let's say they're gonna ask you that they're gonna place one ammeter over here and simply ask you what is the reading of this ammeter. That's what they're asking you. So you're asked to calculate what? I4. So somehow you have to know how can you get to the value of I4. You know that if you want to get the value of I4, you have to calculate the V4, which is equal to V34, because they are a parallel combination that can be calculated by a lot of different steps. So they are going to give you one single common, or they might also give you one single voltmeter over here, and they might ask you that what is the voltmeter reading. This might as well come as an MCQ question, that they might give you that what is the correct voltmeter and ammeter reading. So they're going to give you 4 different columns of voltmeter and ammeter readings, A, B, C, D, and you have to choose the correct value for which this is supposed to be the correct value, and they're going to give you some numbers over here. If it's an MCQ question, these numbers are not going to be convenient enough so that you can do this mathematical calculation orally. So in many cases, you're going to have easier to deal with resistances, which I'm going to show you after a while with examples. But that's how the actual exam questions are going to come up. Actual exam, in the actual exam, you'll never have to deal with such a big number. Actual exam will never ask you to calculate all the variables. I'm asking you to calculate all the variables so that you know for yourself, and I also know for yourself, that you are capable to handle the circuit. No matter which part of the circuit that you're asked to do the calculation for, you know how to handle your shit. This is what I'm essentially asking you to do. বুঝতে পারছি? মানে এত বড় ম্যাথ দেখে মানে ভয় পাওয়ার বা হচ্ছে মানে কি বলবো ফ্রাইটেন হওয়ার কিছু নাই. This is something that is a total large part. In your actual exam, you'll never have to do this whole thing. You will have to do portions of it. But unless you know how to do the whole, you wouldn't be able to do the portion very effectively. That is the whole point. এটা সাবট্রাক্ট করলে কত আসে কি একটু বলো তো আমাকে? 0.1009 মানে 9 এর পরে 0 আসে আর কি. So that's pretty much it. So now if I try to write all the values from this calculation, which is actually quite big value, if I try to write all the answers from this thing, why should I write? Okay, I can try writing here. Common resistance was calculated to be, if I write all the answers in 3SF now, 17.1. Main current was calculated to be 0.255 ampere, and I1 was also the same value, I2 was also the same. We should write the value of I3 and I4 individually. How much did we get for I3? 0.1455. So I can write 0.146, and I4 was calculated to be 0.109. V1 was calculated to be 2.55 volts. V2 was calculated to be 5.09 volts, and then V3 equals to V4, where both of them are calculated to be 4.36. So this is the total answer. I should also definitely write the units. Never miss or mess up your unit. So this is the total answer. Now, if you have a look over here, that all of these answers up to 3SF values, they are perfectly matching with each other. If you add up these two numbers, you're gonna get this number exactly. If you add up this and this, don't add this twice. If you add these three together, you're gonna get perfectly 12. You're not gonna get anything else. এই তিনটা একটু অ্যাড করে দেখো তো পারফেক্টলি 12 আসে কিনা। 2.55 plus 5.09 plus 4.36. How much do you get?
And
You get exactly 12, right? Do you get any fraction?
exactly true.
You don't get any fraction. The reason you could have such matching and complete values is because we dealt with up to 4 decimal places numbers for our calculation, so that our rounding of error ultimately did not cause any significant variation for our final 3SF value answers. এইটা পুরোপুরি বুঝা গেছে কিনা সবার? আমি একটু জুম আউট করে দেখাই so that the whole picture can be within view. But did this whole thing make sense?
I have a question.
Yes, please go ahead.
Mark scheme, is there a range of answers that we can apply for?
In the mark scheme, if there is a change of answer.
Range of answer, range.
Oh, acha, yeah, I can tell you this thing is that ideally what they do in the mark schemes is that for mathematical questions of your paper 2 answers, paper 2, remember the structured question on paper, in the paper 2 answer, they don't usually give a range. Unless you are supposed to calculate some value from the graph, usually there is no range. What they usually do, let's say a number is, let's say this number that we calculated, which one? Let's say this number is 0.2545. Okay. So if a 3SF value is given as 0.25, they might actually write the mark scheme like this. I mean, for this calculation, they might actually write down a mark scheme like this: 0.26 ampere. This is gonna they write in direct out, or they can write in this and to be what can I say? To be merciful. What can I say? To be more to be accepting the other higher decimal places number, they might actually mention all the other in between numbers. For example, they might write or 0.255 ampere or 0.2545 ampere. So if they are going to accept some higher decimal places number, they are gonna give all the numbers exactly. They're not gonna give you a range that this answer is acceptable from this much to this much. Do you get my point?
Yes, sir.
So the whole point is that, or they might actually mention not mention this. They might only mention this much. That is 0.2545. Now, if you want to round this into up to, if you want to round this up to what? Sorry, no, this is not supposed to be 0.25. This is supposed to be 0.25 only. আচ্ছা এই যে এখানে ভেজাল হইতেছে আচ্ছা let me cut this off and let me talk to you about this thing once again. Have a look. If we round this of this number in up to 2SF, I mean, this was our main number, which is rounded up to this decimal place. This decimal place was rounded. If we round this number up to 3SF, we can write 0.255. If you round this off once again to 2SF, you're going to get 0.26. However, if you round this directly to 2SF, what do you get?
4.25.
0.25. So do you see what I'm saying? This was the first round of to 3SF. This was the second round of two from the 3SF, we rounded to 2SF, and this is a direct round of to 2SF. And we have two different numbers. These two numbers are not same. Don't consider this difference negligible. This is not a negligible difference. These two differences are not same. Now, my question: which one do you accept?
0.26.
You do not accept 0.26. You have to accept 0.25. 0.25 is the correct response. If you are going for 2SF value, 0.25 is the only correct response. I'll tell you why. You should not ever do a double rounding from a single number. That is not how math works. You press these numbers within a calculator, 12 divided by 47.1429, and then you get a large number within your calculator display, 10-digit display. And then you either choose to write up to 4 decimal places, 6 decimal places, or 2SF or 3SF. You do your rounding off from the whole large number of your calculator display once. You do not ever do two different rounding off, consecutive rounding off from a single number. That is wrong. Do you get my point? But এখানে দেখো রাউন্ডিং অফ করলে কিন্তু এটা আসছে, সো এটা কখনোই কারেক্ট আনসার হবে না. 0.26 is never going to be a correct answer, acceptable answer for this math. If someone has to write the answer into 2SF, they should write 0.25. If someone writes the answer in 3SF, they should write the answer 0.255. These are the correct answers which should be mentioned in the mark scheme, but not the range. That's the answer to your question, that whether should we have any range or not. You are never going to have a range for a paper 2 question. I have not seen, unless you are doing a calculation from a graph. For the case of graph, usually they give us a bit of a range, because graph within the graphs, whenever you are trying to draw a base fit line, different persons' judgment for base fit line can be different. Different persons' judgment for a proper tangent can be slightly different. So the gradient line can be slightly steeper or slanted for different students for their understanding. So typically for those kind of cases, they give a bit of a range. But for other mathematical numerical value questions, they don't ever give you a range. What they will do, they will give the individual value of different SF values, individually mention them. And if your answer perfectly matches for your given SF number answer, then you're going to score that mark. Otherwise, you will not score that mark. It's a 0 and 1. It's a yes or no. There is no halfway point. There is no range. Does that answer your question?
Yes, sir.
Good. পোলমান, এই কনফিউশনটা সবাই বুঝছো কি? ক্লিয়ার হয়েছে এটা?
Sir.
All right. So we can go for a second circuit right now, which is gonna be once again a pretty simple second circuit. I would like to draw at the bottom. আচ্ছা, এখানে থাকা আপাতত পরে উঠায় নেবে. The second circuit that I can draw can be once again a very simple circuit. We can have actually, how about so how would you describe this circuit? How do you describe this combination?
So R2 and R3 are in series.
Good.
R1 and R4 in parallel, and the R2, R3 series are in parallel with the R1, R4 parallels. Something like that.
Yeah, this will work, but this has one extra step that you might be able to avoid. So এটা কি আসিফ ছিল নাকি সামি ছিল?
Classes.
আচ্ছা আসিফ। What Asif just said is perfectly all right, but what he said that R1 and R4 in parallel, R2 and R3 are in series, and then he said this parallel combination is in parallel with the series combination. That's what you said, right?
Yes, sir.
This is okay. This is perfectly all right. There's no error in it. This is perfectly mask-showing description, no big deal. But I would go for a bit more holistic approach. Is that what I want you to see, that whenever the current is going to come out from the main battery, oops, whenever the current is going to come out of the main battery over here, this current ultimately this current is going to split into three ways. 1, 2, 3. These are the three different pathways the current is going to take go out. Now, intentionally, I did not give you a common junction point. I gave you one junction point over here. So uh, one part of current that flows in here and two parts current that flow in through here, and those two currents are going to split over here and eventually become three parts current. So there is a bit of a choice of connection point, but I'm giving you this kind of a combination because this is the most common type of parallel combination that you're going to come across in your actual papers. So you have to get acquainted with this shape. Bottom line, the current is getting divided into three branches. Within this parallel combination is made up of three branches. So I'm going to describe this parallel combination preferably with three branches other than dividing them in 2 and 2. So if I was writing the description of this circuit, this is how I would write for a single sentence description, is that R1, comma, R4, comma, series combination of R2 and R3, comma, are in parallel with each other. I'll say this again. Have a look at the circuit and listen to me. R1, comma, R4, comma, series combination of R2 and R3, comma, are in parallel with each other. Do you understand what I'm saying? I have no idea how many pieces today's class is gonna be. I mean, do I have to use an additional video recording device to ultimately add up all those videos one after another? So rendering takes a million hours. I don't know. Okay, anyway. Hold on, কথা শোনা যাচ্ছে?
Yes, sir.
আচ্ছা. So this is the description of one single line description that I prefer, that R1, R4, series combination of R2 and R3 are in series. এই পর্যন্ত বুঝা গেছে কিনা? তোমরা এই সার্কিটটা আঁকো এবং নিচে ডেসক্রিপশনে এটা লিখো। যদি তোমরা দুই সেন্টেন্সে লিখতে চাও, if you want to write it into two sentences, which I do not recommend at this point, but you can also write that R2, R3 are in series, full stop. That's your first sentence. You're starting from the most intricate part of the circuit, inside part of the circuit, and then you can write this series combination is in parallel with R1 and R4, or you can say that R1, R4 and the above mentioned series combination are all in parallel with each other. That can also work, equally work. So once you have done the writing the description of this whole circuit, now we're going to start to do the total calculation of this circuit. So the first thing that I'm going to calculate for this circuit is going to be, let me use blue maybe. I'm going to try to calculate the total resistance of the circuit. Have a look. This is how I'm going to write. This is going to be value পরে বসে আগে symbol দিয়ে লিখি, R1 inverse 1 plus R4 inverse 1 plus R2 plus R3 whole inverse 1, this whole thing inverse 1. Check out this formula and see if it makes sense with you. Three things in parallel. That's why we had within the bracket three inverses. Out of those three things, one of them was the series combination. That's why within the bracket we have an expression for a series combination. Does the formula make sense?
C0 power inverse coming.
Oh, because this inverse is for the three individual components. For example, if this was a single resistor of, let's say, R5, how do you write this? R1 inverse plus R4 inverse plus R5 inverse 1, right?
Got it, sir. Got it.
Yes, sir.
Yes, sir.
দেখো সবাই এই ফর্মুলাটা সবাই প্রপারলি বুঝতে পারছো কিনা? Does this formula make proper sense? Well, if it does, then how about you put those values and come up with a number? So 10 inverse plus 40 inverse plus 50 inverse bracket inverse 6.8966. There's a value that I'm getting. Someone please confirm.
Yes, it's all right.
So therefore, main current of the circuit should be V divided by total resistance, which is 12 divided by 6.8966. Did you get exactly 1.74?
Yes, sir.
Wow. Okay. I don't know how that happened, but I'm
Not
happy.
exactly like rounding.
I did not use this value. I used the answer value from the calculator because that's even more precise. So I used 12 divided by answer. Whatever I got from here, I used that one. So that gave me exactly 1.74, nothing else after that. So I'm going to write 1.74. So one thing, follow on. In this case, you should see that this 12 volt is applicable across the whole parallel branch, which means each parallel branch is gonna get the same voltage as the supply, which means I can write over here. This is actually one of my answers. I'm gonna not gonna. This is actually this is also one of my answers. So this is ANS. This is also answer. And now I have to go ahead and do the calculation. So what I'm gonna write over here that the supply voltage 12. Let's say this is our 12 volt is equal to V1 is equal to V4, which is also equal to the combination of 2 and 3. So combination of 2 and 3 in this case I'm writing as V23. V23 means the combination of 2 and 3. In this case is combination, so we can handle that later. But does this sentence make sense? This is very important that you understand this sentence very clearly. And also the why part of it. এই লাইনটা কেন কারেক্ট এটা বুঝতেছো সবাই?
Yes, sir.
Because they are in series parallel combination. They are in parallel combination. The voltage across all the branches of a single parallel combination are exactly equal to each other. That's why this is applicable. So I now know V1 and V4. So these two answers are already known to us. Just a second. Or sir, class নিচ্ছি একটু পর কল করছি. So we do know these values. So I can now very easily calculate I1. I1 equals to V1 by R1. I want you to calculate this. Then you can calculate I2 equals to V2 by R2. You should calculate this. And then I23, sorry, I2 now, sorry, my bad, I4. And then I23 should be equals to V23 divided by R23. This is why you can calculate this. এটা কত আসে? 1.2. এটা কত আসে? 0.30. বুঝেছে বলবান?
Yes, sir.
এটা কত আসবে?
0.24.
So এই জিনিসটা বুঝো I23 টা ক্যালকুলেট করলাম হচ্ছে সমস্ত দিয়ে I23 should be equals to the total voltage across 2 3 combination divided by the resistance of the 2 3 combination. So 12 divided by 50 gives you 0.24, which happens to be equal to I2 and I3 because R2 and R3 are in series combination. The current that will flow through this path will be same for both of them. So I23, the combination current of the series combination is exactly equal to the individual currents because there is no branch over here. There is a single pathway, so the same current flows through all the series components. So this is one way you can calculate the I23. You can do this, or you can do I23 can be also calculated as I minus I1 plus I4. Check this out. Check out this formula and look at the second and try to understand the significance of this line, this OR part. Have a look if this subtraction makes sense. Everyone, please. The main current comes in. Two of the branch currents are already known to us. So if you want to calculate the third branch current, we can very easily subtract these two from the main to get the third. We pretty much get the exact same value, which is nice. So দুটো যে কোনো একটা করলেই হবে, কোনো সমস্যা নাই. And because we have already found out the I2 and I3, the obvious next step is to calculate the V2 equals to I2 into R2. You calculate this much, and then V3 equals to I3 into R3. You also calculate this much. এই ভ্যালু দুটো কত কত আসে আমাকে বলো.
So V2 9.6 আসে.
কেমনে 0.24 না, .24 into 20.
Because I took 40. So
It's okay, no problem, no problem. করো, সমস্যা নাই, মন দিয়ে করো, ভুল হলে প্রবলেম নাই, কারণ ক্লাসে ভুল করাটা পারফেক্টলি অলরাইট। পরীক্ষা না হলে হয়েছে, মানে হচ্ছে একদম অলওয়েজ পরীক্ষা না হলে হয়েছে। সো এই হচ্ছে দুইটা ভ্যালু। ভিজিটাকে এখান থেকে ডিরেক্টলি মাল্টিপ্লাই করে বের করলাম বিকজ ইট ওয়াজ ইজিয়ার টু ডু, বাট ওয়ান্স अगेन ইফ ইউ ওয়ান্টেড টু সাবট্রাক্ট দিস, ভিজিটাকে আমরা আইদার ওয়ে ভিজি কে এভাবে ক্যালকুলেট করতে পারতাম, v3 ইকুয়াল টু v মাইনাস v2, সো 12 মাইনাস 4.8, এটা করলেও তুমি 7.2 পাইতা। So এই হচ্ছে total calculation of this parallel combination. Parallel combination calculation apparently is a slightly bit similar, slightly was more simpler compared to the series combination. This is just a property of the circuit. This is how the circuit works out. I mean, I don't have any control on how which one is easy or difficult. But one of the reason this calculation became far too simpler because all of these numbers happen to become very small by their own virtue. So we didn't have to bother for much decimal places. Once again, if you are trying to write your answer in 3SF, but you have a value of 0.24, if you want to write this answer as 3SF, what do you write?
just 0.24 হবে না?
0.2. I mean, 12 by 50 gave me exactly 0.24. There is no variation of it. So, but if I still want to write this answer as a 3SF value in my answer of the dot 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 space in the question paper, how should I write this? 0.24 what?
0.
We should give simply one extra to make the SF value go higher. That's it. But in physics, it is highly discouraged. You should never impose increased number of zeros to increase SF values, because that in many cases represent a false sense of accuracy. So in physics, we don't ever appreciate this. I mean, if your calculated number is 2SF, you better stick to 2SF for all of your answers and be contented about it. Content about it, not content. Be content about it, and that's okay. But do not ever preferably don't ever increase one extra zero after the decimal point, because that gives us fake sense of higher accuracy of the calculation and the data collection process, which is not a good idea for uh, accuracy sake in many cases, which you're going to learn more detail about in our S level. There is a whole chapter dedicated for precision and accuracy. We're going to learn about those things. Any question about this circuit so far? Anyone? মেথোডোলজিটা বুঝা গেছে কিনা? বলো মানে ঠিক আছে, সার্কিটটা ঠিক আছে তাহলে? আচ্ছা, এখানে আমি তোমাদেরকে যদিও we have 10 minutes of time, yes, so I'm gonna try to get you started on another circuit which will be homework eventually. So this is our circuit number 3. So check out this circuit. We have 6 resistors over here, a bit more than earlier, and we have a 9-volt supply, and we are asked to solve this circuit. Means you have to basically calculate everything, which I hope that you can do, provided you can have a good and appropriate description of this circuit. So I want all of you to copy this circuit in your copy. Take a good look. Try to visualize the flow of current from the positive end of the battery all the way back to the negative end of the battery. Try to visualize that current flow path and write a full description of the circuit to your best capability. Only the description. I'm going to ask about this description after a while. I'll give you 5 minutes to think about this and write the description of the circuit. Try. So we're back after the given time to write about this. So I'll take open sharing. Anyone? Or I could ask one by one for everyone. Yes.
So the series R1, R5 is in parallel to the series R2, R6, and that entire combination is in series with R4.
How about R3?
I don't think R3 and R4 are in series.
What
They
you
have to be
wrote,
on the same circuit line, right?
what you wrote is perfectly all right. What you just need to add one more word, that parallel combination is in series with R3 and R4, or R4 and R3. বুঝছো?
Yes, sir.
Anyone else?
Can I write in the chat box?
Yeah, sure. But write for everyone. Don't write me personally. R1 and R5 are in series while R2 are also in series with them being in parallel combination. With each other. And also, Samira, your decision for started out good, and then you messed up somewhere within the part for also to the series combination. I think you are pretty confused to write it that way. I think it's so because if you write that also, have a look. R1 and R5 are in series, which is good, while R2 and R6 are also in series with them being in parallel combination. So you have described this parallel combination perfectly. Then you have written and also to the series combination of R4 and R4, which means what you are proposing that these two parallel combination and they are also in parallel with the series combination of R4 and R3. That's what you are proposing. Do you understand my understand it from this writing?
Yes, sir.
So you did not want to mean that. What you want to mean that this parallel combination is in series with R4 and R3, right?
Yes, sir.
Good. So try to correct it that way. If anyone else, do you understand the whole description of this whole circuit? For those of you who still have some confusion, I'm just saying my version of it. It's pretty much the same for what many of the classmates did propose. I'm going to write it in this manner. Series combination of R1 and R5 and series combination of R2 and R6 are in parallel with each other. Full stop. That's going to be my first sentence. I'll say this again. Series combination of R1, R5 and series combination of R2 and R6 are in parallel with each other. Full stop. This parallel combination, comma, R4, comma, R3 are in series. Or if you want to start from the positive end of the battery, you could also write in the second sentence that R3, comma, R4, comma, this earlier mentioned parallel combination are in series. That also works. So if you understand this part of this description, then you need to calculate the total resistance. I'm just showing you a bit of a step for the combination for the calculation for the total resistance. Then I'm going to call it a day. What I want you to do is that you calculate R15 individually. R15 equals to 10 plus 50 equals to 60. R26 equals to R20 plus 20 plus 60 equals to 80. Then you calculate the total R1526, which is going to be equal to what? 16 verse 1 plus 18 verse 1 whole inverse 1. This is the total resistance of the whole parallel combination. And then you go ahead and calculate the total resistance of the circuit, which would be R3 plus R4 plus R1526. So you just write these values 30 plus 40 plus whatever you get from there. You place it, and eventually that's how you can calculate your total resistance. I want you to calculate this in between values because you're going to be needing these in between values after a while. So having them available on your working can prove to be very useful later on. বুঝতে পারছি?
Yes, sir.
Do you understand what up to this point very clearly that what do I mean by these large numbers or large numbers? R15 means what?
The combination of resistor 1 and 5.
The combined resistance of resistance 1 and 5. Beautiful. R1526 means the total resistance of the combination that is made up with R152 and 6. So I mean, it doesn't matter that a 15 and 26 should be in series or parallel. It simply means the way they are arranging the circuit and calculating in that manner, but this is the total resistance of the combination made up with all those components. That's what I meant. All right, kids, thank you very much. Your homework would be to try and solve this entire circuit. So give your best try. If you get stuck anywhere, we'll definitely start this discussion from this point in our next class. Thank you very much. Assalamu alaikum.